Habitat and adaptation. The sunlit angler inhabits the mesopelagic zone, also known as the twilight zone, which ranges from 200 to 1,000 meters below the ocean surface. Unlike its deep-sea relatives, the sunlit angler has adapted to the increased light levels and slightly warmer temperatures of this zone. Physical characteristics. Size and shape. The sunlit angler is slightly larger than its deep-sea cousins, reaching lengths of up to 1.5 meters, 4 feet 11 inches. Its body is more streamlined to allow for faster swimming in the more dynamic upper waters. Coloration. To blend in with the dappled light of the mesopelagic zone, the sunlit angler has developed a counter-shaded coloration. Its dorsal side is a dark blue or green, while its ventral side is a silvery white, making it less visible from both above and below. Bioluminescence. While it retains the iconic bioluminescent lure, or esca, on its head, the sunlit angler's light-producing organ has evolved to emit a broader spectrum of colors. This adaptation helps it attract a wider variety of prey that are drawn to different wavelengths of light. Behavior and diet. Hunting strategy. The sunlit angler uses its bioluminescent lure to attract prey, much like its deep-sea relatives. However, it has also developed a more active hunting strategy, using bursts of speed to chase down smaller fish and squid that are abundant in the mesopelagic zone. Diet. Its diet consists primarily of small fish, crustaceans, and cephalopods. The sunlit angler's larger size and more powerful jaws allow it to tackle a wider range of prey compared to its deep-sea counterparts. Reproduction. Mating behavior. The sunlit angler exhibits a unique mating behavior where males are significantly smaller and attach themselves to the females. This parasitic relationship ensures that the male is always available to fertilize the female's eggs when she is ready to spawn. Eggs and larvae. The eggs are buoyant and float closer to the surface, where the larvae hatch and begin their life in the nutrient-rich upper layers before gradually descending to the mesopelagic zone as they mature. Ecological role. The sunlit angler plays a crucial role in the mesopelagic ecosystem. As both a predator and prey, it helps maintain the balance of species in this zone. Its bioluminescence also contributes to the unique light dynamics of the twilight zone, creating a fascinating interplay of light and shadow. Evolutionary history. Origins. The sunlit angler's ancestors were deep-sea anglerfish that thrived in the abyssal depths of the ocean. These early anglerfish were well adapted to the extreme conditions of the deep sea, with specialized features like bioluminescent lures and highly sensitive sensory organs to detect prey in the pitch-black environment. Migration to the mesopelagic zone. Over millions of years, some populations of deep-sea anglerfish began to migrate towards the mesopelagic zone. This migration was likely driven by changes in oceanic conditions, such as shifts in temperature, pressure, and the availability of prey. The mesopelagic zone offered a new ecological niche with abundant food sources and less competition from other deep-sea predators. Adaptations to new environment. As these anglerfish populations settled into the mesopelagic zone, they underwent several key adaptations. Enhanced vision. To cope with the increased light levels, the sunlit angler developed larger and more complex eyes, allowing it to see better in the dimly lit waters of the twilight zone. Coloration changes. The need for camouflage led to the evolution of counter-shaded coloration, helping the sunlit angler blend into its surroundings and avoid predators. Bioluminescent modifications. The bioluminescent lure evolved to emit a broader spectrum of colors, making it more effective at attracting a diverse range of prey in the mesopelagic zone. Diversification. As the sunlit angler adapted to its new environment, it began to diversify into various subspecies, each with unique traits suited to specific niches within the mesopelagic zone. Some subspecies developed longer lures to attract prey from greater distances, while others evolved more streamlined bodies for faster swimming. Ecological impact. The sunlit angler's presence in the mesopelagic zone had a significant impact on the local ecosystem. As a new predator, it helped regulate the populations of smaller fish and invertebrates, contributing to the overall balance of the food web. Its bioluminescence also added to the unique light dynamics of the twilight zone, influencing the behavior of other species. Current status: today, the sunlit angler is a well-established species in the mesopelagic zone, continuing to thrive and evolve. Its evolutionary journey from the deep sea to the twilight zone is a testament to the adaptability and resilience of life in the ocean. The evolution of the sunlit angler likely began during the Cenozoic era, specifically in the Miocene epoch, which spanned from about 23 to 5 million years ago. This period was characterized by significant changes in oceanic conditions, including shifts in temperature and sea levels, which could have driven deep-sea anglerfish populations to explore new habitats. During the Miocene, the oceans were teeming with life, and the mesopelagic zone offered a relatively untapped ecological niche. The gradual migration and adaptation of deep-sea anglerfish to these upper layers would have taken millions of years, with natural selection favoring traits that improved their survival and hunting efficiency in the twilight zone. Taxonomic classification. Kingdom, Animalia. Phylum, Chordata. Class, Actinopterygii. Order, Lophiiformes. Family, Melanocetidae. Genus, Mesolophius. Species, Mesolophius lucens.